Dinosaurs After Dark. Chapter 1. Welcome to the Age of Dinosaurs. Dinosaurs first appeared during the Triassic Period, approximately 250 million years ago. This period marks the beginning of the Mesozoic Era, often called the Age of Reptiles. At this time, all of Earth's continents were joined together in a single massive supercontinent known as Pangaea. The climate was generally dry, with hot deserts spreading across much of the landmass. There were no flowering plants, no grasses, and no birds. Vegetation mostly consisted of ferns, conifers, cycads, and horsetail plants. The first dinosaurs evolved from a group of reptiles called archosaurs, which also gave rise to crocodiles and pterosaurs. These early dinosaurs were relatively small and lightly built. They walked on two legs and had long tails for balance. One of the earliest known dinosaurs is Eoraptor, which lived around 231 million years ago in what is now Argentina. Eoraptor was about 1 meter long, weighed around 10 kilograms, and likely fed on small animals and insects. Its lightweight skeleton and bipedal stance suggest it was fast and agile. Another early species is Herrerasaurus, which lived during the same time and region. It was larger, around 3 to 4 meters long, and had sharp teeth, claws, and strong hind limbs. Herrerasaurus is considered one of the first relatively advanced theropods, the group that would eventually include Tyrannosaurus rex and modern birds. In the Triassic, dinosaurs were not yet the dominant animals. Other reptiles, such as Rauisuchians and cynodonts, mammal-like reptiles, were more widespread and sometimes larger. But over time, environmental changes and mass extinction events allowed dinosaurs to rise in diversity and ecological importance. The end of the Triassic period, around 201 million years ago, was marked by a significant extinction event. Roughly 50% of marine and terrestrial species went extinct, clearing ecological space for dinosaurs to thrive and diversify in the following Jurassic period. This marked the beginning of their reign, which would last for more than 160 million years. Chapter 2. The Triassic World. The Triassic period lasted from approximately 252 to 201 million years ago. It was the first period of the Mesozoic Era, which includes the Triassic, Jurassic, and Cretaceous periods, the entire span during which dinosaurs lived. During the early Triassic, Earth was recovering from the most severe extinction event in its history, the Permian-Triassic extinction, also known as the Great Dying. This event wiped out around 90 to 95% of marine species and about 70% of terrestrial vertebrate species. As life rebounded, the Triassic saw the rise of many new types of reptiles, including the ancestors of crocodiles, lizards, pterosaurs, and eventually dinosaurs. Pangaea, the single supercontinent, stretched from the northern to the southern polar regions. This resulted in very large and often extreme climate zones, including vast deserts in the interior of the continent due to the lack of coastal moisture. Despite these conditions, a wide variety of life evolved. Among the dominant reptiles were the archosaurs, which means ruling reptiles. Archosaurs split into two major groups. One led to modern crocodiles and their extinct relatives, the pseudosuchians. The other led to pterosaurs, flying reptiles, and dinosaurs. Some of the earliest true dinosaurs during this time included Eoraptor, a small, lightly built biped; Herrerasaurus, a more advanced carnivore; Chelophysis, one of the earliest well-known theropods, found in large fossil beds in what is now New Mexico, USA. Chalophysis was about 3 meters long and weighed around 20 to 30 kilograms. It had a slender body, long tail, and sharp teeth, likely feeding on small animals and possibly even scavenging. During the late Triassic, sauropodomorphs also began to appear. The early ancestors of the giant long-necked dinosaurs like Brachiosaurus and Diplodocus. Examples include Plateosaurus, which could grow up to 10 meters in length and weighed several tons, although it likely still walked on 2 legs. In terms of plant life, there were no flowering plants yet. The landscape was dominated by conifers, cycads, ginkgos, and various types of ferns and seed ferns. These plants formed the basis of early herbivorous dinosaur diets. By the end of the Triassic, another major extinction event occurred, possibly caused by massive volcanic eruptions as Pangaea began to break apart. This extinction cleared out many competing reptile groups, allowing dinosaurs to become the dominant land animals during the Jurassic Period. Chapter 3: Jurassic Giants. The Jurassic Period began around 201 million years ago and lasted until approximately 145 million years ago. It was a time of dramatic change and expansion in dinosaur evolution. With the extinction of many competitors at the end of the Triassic, dinosaurs became the dominant terrestrial vertebrates. During the Jurassic, they diversified rapidly and spread across the gradually separating continents. One of the most iconic developments of the Jurassic was the rise of the sauropods, the giant, long-necked, plant-eating dinosaurs. Sauropods. Sauropods were among the largest animals to ever walk on land. They are characterized by extremely long necks, small heads, long tails, pillar-like legs, enormous body size. Famous Jurassic sauropods include Brachiosaurus. This dinosaur could grow over 25 meters long and weigh more than 50 tons. Unlike most sauropods, Brachiosaurus had longer front legs than back legs, giving its body a sloped appearance and allowing it to browse tall treetops. Diplodocus. Known for its exceptionally long tail and neck, Diplodocus was lighter than Brachiosaurus and could reach up to 27 meters in length. It may have used its tail like a whip for defense or communication. Apatosaurus, formerly known as Brontosaurus, a name now sometimes revalidated for a separate genus. Apatosaurus was large and robust, with a shorter neck than Diplodocus, but a more massive body. Sauropods likely traveled in herds and may have migrated across large distances in search of food. They fed primarily on high vegetation, including conifers and ferns, stegosaurs, and other herbivores. The Jurassic also saw the rise of armored herbivores like Stegosaurus. Stegosaurus lived around 155 to 150 million years ago. It was about 9 meters long, with a small head, short front legs, and 2 rows of large upright plates running down its back. Its tail featured 4 long spikes, known as the thagomizer, used for defense. Despite its intimidating tail, Stegosaurus had a very small brain, roughly the size of a walnut. However, it was well adapted for its ecological niche, and likely lived in groups or family units. Early predators. The Jurassic Period also featured large carnivorous theropods. Allosaurus. This predator lived in North America and measured around 8 to 12 meters long. It had sharp teeth, strong legs, and 3-fingered hands with curved claws. Allosaurus likely preyed on large herbivores, such as sauropods and stegosaurs, and may have hunted in groups. Other predators included Ceratosaurus, with a horn on its nose and blade-like teeth; Megalosaurus, one of the first dinosaurs ever named in scientific literature; ecosystems. Jurassic ecosystems included forests of conifer trees, ginkgos, cycads, and ferns. The climate was warm and humid, with lush environments that supported vast herds of herbivores and their predators. At sea, marine reptiles such as ichthyosaurs and plesiosaurs thrived, though they were not dinosaurs. In the skies, pterosaurs, flying reptiles like Pterodactylus, soared above. By the end of the Jurassic, dinosaurs had colonized nearly every major landmass, setting the stage for even greater diversity during the Cretaceous period. Chapter 4. The Cretaceous Kingdom. The Cretaceous period lasted from approximately 145 to 66 million years ago, making it the longest period of the Mesozoic Era. It was a time of significant geological, climatic, and biological change, and the final chapter in the reign of the non-avian dinosaurs. During the Cretaceous, the continents continued to drift apart, breaking away from the supercontinent Pangaea. This movement created isolated landmasses, which led to regional variations in dinosaur species and ecosystems. Flowering plants, or angiosperms, first appeared in this period. This evolutionary breakthrough transformed landscapes and introduced new food sources for herbivorous dinosaurs, iconic dinosaurs of the Cretaceous. The Cretaceous is known for some of the most famous and well-researched dinosaurs in history. Tyrannosaurus rex. One of the most iconic predators of all time, Tyrannosaurus rex lived around 68 to 66 million years ago in what is now Western North America. Key facts: length up to 12.3 meters, about 40 feet. Weight around 9 tons. Bite force estimated up to 6 tons, among the strongest of any land animal. 2 strong legs, tiny but powerful forearms, and a massive skull with banana-sized teeth. T-Rex was both a predator and a scavenger. It likely fed on large herbivores like Edmontosaurus and Triceratops. Triceratops. This 3-horned herbivore was one of the last non-avian dinosaurs. It lived alongside T-Rex and is known for its large frilled head and facial horns. Key facts: length about 9 meters, 30 feet, and weight around 6 to 12 tons. It had a parrot-like beak, powerful jaws, and rows of shearing teeth for eating tough vegetation. Triceratops may have used its horns for defense, mating displays, or in battles with rivals. Velociraptor. Velociraptor was a small, fast, feathered predator, very different from its depiction in popular films. Key facts: length around 2 meters, 6.5 feet, weight roughly 15 to 20 kilograms, about 30 to 45 pounds. Lived in what is now Mongolia. Had feathers, sharp claws, and a curved killing claw on each foot. Velociraptors likely hunted in packs or pairs and may have used ambush tactics. Other notable Cretaceous dinosaurs. Ankylosaurus, a heavily armored herbivore with a clubbed tail used for defense. Pachycephalosaurus, known for its thick, dome-shaped skull, possibly used in headbutting contests. Parasaurolophus, a hadrosaur with a long, curved crest on its head, which may have been used to produce sounds. Evolution of feathers and birds. One of the most important discoveries in dinosaur science is the connection between theropods, like Velociraptor, and modern birds. Fossils from the Cretaceous show clear evidence of feathers in many small theropods. Some species, such as Microraptor, had 4 wings, feathers on both arms and legs. and may have glided through the trees. Others, like Archaeopteryx, showed a combination of bird and dinosaur traits, such as teeth, claws, and a long, bony tail. Today, birds are recognized by scientists as living dinosaurs, descended from small feathered theropods, flying, and marine reptiles. Although they are not dinosaurs, pterosaurs like Quetzalcoatlus dominated the skies during the Cretaceous. Quetzalcoatlus had a wingspan of up to 10 to 11 meters, making it one of the largest flying animals in history. In the oceans, large marine reptiles like Mosasaurus, Plesiosaurs, Elasmosaurus ruled the seas. These animals, though reptilian, were not related to dinosaurs. Chapter 5: The Smallest Dinosaurs and How They Lived. When most people think of dinosaurs, they picture massive creatures like Tyrannosaurus rex or Brachiosaurus. But not all dinosaurs were giants. In fact, many species were quite small, some no larger than modern birds or domestic animals. These small dinosaurs were just as diverse and important as their larger relatives, and many offer valuable clues about dinosaur behavior, reproduction, and evolution. Small theropods. Theropods were mostly bipedal, carnivorous dinosaurs, and many of the smallest known species fall within this group. Microraptor lived around 120 million years ago during the early Cretaceous in what is now China. It was about the size of a crow, with a body length of 70 to 90 centimeters and weighed less than 1 kilogram. Key features: it had feathers on all 4 limbs, giving it a unique 4-winged appearance. Microraptor may have glided between trees, using its feathered limbs like wings. Its diet likely included small mammals, birds, insects, and possibly fish. Compsognathus. Compsognathus lived in the late Jurassic Period and was originally one of the smallest known dinosaurs. Key facts: length, about 1 meter, weight, around 3 to 4 kilograms, lived in what is now Europe. Fast and agile, it likely preyed on small vertebrates and insects. Trudon was a small bird-like theropod that lived in the late Cretaceous and is often considered one of the most intelligent non-avian dinosaurs. Key traits: large brain relative to body size, sharp teeth, keen senses, and forward-facing eyes for depth perception. Possibly omnivorous, feeding on both plants and animals. Dinosaur eggs and nests. Fossilized dinosaur eggs provide valuable information about reproduction and parental behavior. Dinosaur eggs have been found on every continent. Most were round or oval in shape, with hard, calcified shells. Some species, like Maiasaura, built large nesting grounds and may have cared for their young after hatching. The name Maiasaura means good mother lizard, evidence suggests that hatchlings stayed in the nest and were fed by adults. Other discoveries show clutches of eggs arranged in circles, possibly laid by sitting females, similar to how modern birds nest. Some dinosaurs, like Oviraptor, were once thought to have stolen eggs, but further evidence revealed they were protecting their own nests. Fossils have even been found with adult oviraptors preserved in a brooding position over their eggs. Growth and development studies of bone structure show that many dinosaurs grew rapidly after hatching, much faster than modern reptiles. Sauropods, despite their massive adult size, likely hatched from football-sized eggs. Growth rings in bones suggest some species reach full size in as little as 10 to 20 years. Depending on species, smaller species may have reached maturity even faster. Feathered dinosaurs likely had precocial young, meaning they were mobile soon after hatching. This is seen today in many ground-nesting birds like ducks and chickens. Importance of small dinosaurs. Small dinosaurs help paleontologists understand the transition from dinosaurs to birds, study behaviors that don't fossilize easily in large species, explore ecological roles such as insect control, scavenging, or seed dispersal. They remind us that dinosaurs weren't just towering beasts. They were complex, adaptable, and present in nearly every niche of prehistoric life. Chapter 6. What did dinosaurs sound like? One of the great mysteries of paleontology is the question, what did dinosaurs sound like? Unlike bones and teeth, sounds do not fossilize. There are no direct recordings or preserved vocal cords from the age of dinosaurs. However, scientists can make educated guesses by studying the anatomy of dinosaur skulls and airways, comparisons with modern animals, especially birds and reptiles, fossil impressions of soft tissue, and evolutionary relationships, vocal anatomy. To produce sound, animals need structures like vocal cords, windpipes, or special resonating chambers. Most modern reptiles, such as crocodiles, use a larynx, a structure in the throat, to create low-pitched growls, hisses, or bellows. Modern birds, which are living descendants of theropod dinosaurs, use a different organ called a syrinx. Located at the base of the windpipe, the syrinx allows birds to produce complex sounds, from chirps to elaborate songs. Fossil evidence suggests that some dinosaurs may have had similar vocal anatomy, especially in groups closely related to birds. In 2016, scientists discovered a fossilized syrinx in a bird-like dinosaur called Vegavis from the late Cretaceous. This discovery supports the idea that at least some dinosaurs could produce bird-like sounds. However, since this fossil came from a species very close to modern birds, it's unclear how widespread syrinx-like structures were in earlier or more distant dinosaurs. Possible sounds. While pop culture often portrays dinosaurs roaring, this may not be accurate for many species. Some scientists believe that many dinosaurs made low-frequency rumbles similar to elephant infrasound, hoots or booming sounds like ostriches and emus, hisses, growls, or deep calls like crocodiles or alligators. These types of sounds can travel long distances and are useful for communication over open terrain, attracting mates, warning others of predators, keeping track of group members. Large-bodied dinosaurs like sauropods may have had resonating air sacs in their heads or necks, amplifying deep, low-pitched sounds. Some horned dinosaurs, such as Parasaurolophus, had long, hollow crests on their skulls. Scientists believe these crests acted like wind instruments, possibly allowing them to produce loud, echoing calls for communication. Computer simulations of these skulls suggest that Parasaurolophus could have made low, haunting tones, similar to the sound of blowing across a large bottle. Silent communication. It's also possible that many dinosaurs relied on non-vocal communication. Like modern reptiles and birds, dinosaurs may have flapped wings or arms, displayed feathers or frills, used color patterns for signaling, stomped or drummed the ground, used body posture to show aggression or attraction. These visual and physical signals would have been especially important in open environments where sound didn't carry far. Conclusion. While we may never know exactly what dinosaurs sounded like, modern science allows us to make informed guesses. It's likely that different species made a wide range of sounds, from deep, rumbling calls to sharp, rhythmic chirps, depending on their anatomy, size, and environment. The real dinosaur world was probably much quieter and more varied than the Hollywood version, full of subtle, strange, and fascinating sounds we can only imagine. Chapter 7. The Great Disappearance. The reign of the non-avian dinosaurs ended around 66 million years ago, at the boundary between the Cretaceous and Paleogene periods. This event is known as the Cretaceous-Paleogene extinction, or KPG extinction. It was one of the most sudden and dramatic mass extinctions in Earth's history. The asteroid impact. The leading theory for this extinction is the asteroid impact hypothesis, first proposed in 1980. Key evidence includes a thin global layer of sediment rich in iridium, a rare metal common in asteroids, shocked quartz and glass spherules formed by intense heat and pressure, a massive crater called the Chicxulub crater located beneath the Yucatan Peninsula in Mexico. The asteroid is estimated to have been about 10 to 12 kilometers wide, roughly the size of Mount Everest. When it struck Earth, it released energy equivalent to more than 1 billion nuclear bombs. Immediate effects. The impact would have caused massive wildfires across continents, a global ejecta cloud of dust and debris that blocks sunlight, a sharp drop in temperatures disrupting photosynthesis, collapse of food chains, especially affecting large animals that needed a lot of energy. Marine ecosystems were also devastated by acidification and reduced oxygen levels. Within a short geological time frame, possibly just a few decades to centuries, around 75% of all species on Earth went extinct. This included all non-avian dinosaurs, most pterosaurs, large marine reptiles like mosasaurs and plesiosaurs, many species of plants, plankton, and invertebrates. Why did birds survive? Not all dinosaurs went extinct. Birds, the descendants of small feathered theropods, managed to survive the catastrophe. Several factors may have contributed to their survival. Small body size, which required less food. The ability to fly, allowing escape and migration. Possible nesting and feeding behaviors that adapted better to post-impact environments. Omnivorous diets, giving access to varied food sources. The birds that survived gave rise to all modern bird species, over 10,000 of them today. Other survivors. In addition to birds, other animals that survived included mammals, many of which were small, burrowing, and nocturnal. Amphibians, insects, fish, and reptiles. Certain types of plants and fungi which helped re-establish ecosystems. After the extinction, mammals rapidly diversified, eventually becoming the dominant land animals in the New Age, the Cenozoic Era. Reflections. The end of the dinosaurs was not the end of life. It was a turning point. It reshaped the planet, cleared space for new forms of life, and set the stage for the rise of humans tens of millions of years later. But for over 160 million years, dinosaurs were the undisputed rulers of Earth, adapting to changing climates, evolving into countless forms, and leaving behind a legacy we continue to uncover today. Chapter 8. Dinosaurs Today. Although most dinosaurs went extinct around 66 million years ago, not all of them disappeared. Today, scientists widely agree that birds are the direct descendants of small feathered theropod dinosaurs. This makes them the only surviving group of dinosaurs alive today. Birds as living dinosaurs. Modern birds share many features with their dinosaur ancestors. Feathers first evolved for insulation or display. Feathers later supported flight. Hollow bones, lightweight bones for efficient movement, seen in both birds and small theropods like Velociraptor. Three-toed limbs and beak-like skulls, traits seen in both ancient and modern species. Fossils like Archaeopteryx, with both dinosaur and bird traits, provide a clear link between the two groups. Over time, flightless theropods gave rise to early birds, which survived the mass extinction and diversified into over 10,000 species we know today, from hummingbirds to ostriches. What we're still learning. Paleontology is constantly evolving. New discoveries, especially from China, South America, and Antarctica, continue to reshape our understanding of dinosaur biology, behavior, and evolution. Some areas of active research include coloration. Microscopic structures and fossilized feathers suggest some dinosaurs had iridescent, patterned plumage. Growth rates. Bone analysis shows that some dinosaurs grew incredibly fast, reaching adult size in just a few years. Behavior. Nesting fossils, trackways, and bone beds offer insight into parenting, hunting, and migration. Technology such as CT scanning, isotope analysis, and 3D modeling is helping scientists explore ancient remains in ways never before possible. Why dinosaurs still fascinate us. Dinosaurs hold a unique place in human imagination. They were real, yet they seem almost mythical. Enormous creatures that ruled the earth long before humans existed. Reasons for our fascination include size and power. From towering sauropods to deadly predators, dinosaurs represent extreme forms of life. Mystery. Many questions remain unanswered, leaving room for curiosity and exploration. Discovery. New species are still being found every year, keeping the field of paleontology vibrant. Connection. The realization that birds are dinosaurs allows us to see echoes of the prehistoric world in our everyday lives. When you hear a bird sing, watch one glide through the sky, or see tiny chicks hatch, you're witnessing a living lineage that stretches back over 150 million years. Dinosaurs are not just part of the past. In many ways, they're still here.